Good morning, everybody. I hope you guys are off to a fantastic Monday. So today we are talking about parallel and perpendicular lines. And if you haven't already checked out the 2.2 equations of lines, I highly recommend that you do that before moving into this section. So anyways, what do we know about parallel lines? Well, I know that they never touch, but in relations to things that we've been talking about, so like slope, what is my relationship there? Well, if I count, that means I go up 2 over 1, so my slope here is 2. Well, what about this line here? Well, I went up 2 over 1, so my slope on this line is also 2. So what does that mean that I can say about their slopes? They are the same. So same slopes. Coinciding lines. This is more of a definition that you probably won't hear or see very often, but just in case it comes up, they're lines that are the exact same. And they could be written differently. You might see them as the line that passes through these 2 points. You could see them in different forms, so like y equals negative 2x plus 5. Well, in standard form, we would move that over and we would say 2x plus y equals 5. These are both coinciding lines because they are the same thing. Perpendicular lines. We've heard this word before, linking back for forever ago. Perpendicular, I know that they meet at a right angle, but how do I know that they are indeed perpendicular? I'm not going to pull out a protractor every time and make sure that they measure 90 degrees. So let's look at their slopes and see what we can notice. If I make a triangle based off those things, this blue line, if I go in and count that, I go up 12 and over 4. So for the blue line, my slope is 12 over 4, which reduces to 3 over 1 or just 3, but for right now I'm just going to leave it as 3 over 1. If I look at the green line, so I'm going to move, oh no I'm not, just kidding, let's try that again. I'm going to move these out of the way, and let's see if we can find the slope for the green line. So I'm going to go down and over. So then if I count that, I'm going to go down 1, 2, 3, so down negative 3 and over 1, 2, 3, 4, 5, 6, 7, 9. So then my slope here is negative 3. I'll do this over to the side. Negative 3 over 9, and if I reduce that, that's negative 1 over 3. So then what do I notice? What do I notice is the relationship between the slope of the blue line and the green line? Well, I notice that the 1 and the 3 flopped places in the numerator and denominator, and instead of being positive, I'm negative. So these slopes are what we call opposite reciprocals. O-P-P-O-S-I-T-E, reciprocals. And what that means is opposite would be like the sign. So instead of positive, it's negative, negative goes to positive, or vice versa. And the positive goes to negative, negative goes to positive, and the reciprocal part is that these things swap positions. So 3 is on the top, 1's on the bottom. So for example, if I gave you a original slope of, I don't know, 5/3, my perpendicular slope, and this little symbol right here, the upside down T means perpendicular, would be negative 3 over 5. So it's positive here, negative there, and these two things swapped positions. If my original slope was negative 7/9, then my perpendicular slope would be 9 over 7. Negative went to a positive, and these two things flopped positions. The same thing happens if I have a whole number. So let's say my slope was originally negative 8. Well, that's the same thing as negative 8 over 1. So then my perpendicular slope would be positive 1 over 8. So let's try an example. Write an equation of a line in slope-intercept form that passes through 2, 2 and is parallel to this part. Well, remember from Friday, what are the 2 things that I need to know to write an equation of a line. I have to know a slope, and I have to know a point. Well, I've got the point, it straight up tells me it's 2, 2. My slope, well, we know parallel lines have the same slope, which means the slope here is 3. Parallel means it also has to be 3. So then I like to work in point slope form first, but that's just me. So point slope said y minus y1 is equal to mx minus x sub 1. So I can plug in my point where this is x1 and y1. So I could say y minus 2 is equal to my slope, which was 3, of x minus 2. And we're just going to clean this up to get this in the slope-intercept form. So this is point slope. And I'm going to go ahead and distribute that 3. So y minus 2 is equal to 3x minus 6. Go ahead and add the 2 to the other side. So then y is equal to 3x minus 4. So notice parallel, same slopes, yay, and just a different y-intercept. So there's my answer for example 1. For example 2, write an equation of a line that is parallel to that jazz and passes through that stuff in standard form. Alright, well, again, parallel means same slope. So what is my slope here? Well, y equals like mx plus b. So the number in front of the x is my slope. So my slope is negative 1/3 this time. And my point is negative 9, positive 5. So I still am going to opt to work in point slope where it's y minus y1 is equal to mx minus x1. And this is my x1 and y1. And then we're just going to plug in. So I've got a y minus 5 is equal to my m, which was negative 1/3, of x minus negative 9. Well, these two negatives are going to turn into a positive, and then I'm going to opt to distribute. Well, better yet, talk about it here. This is my point slope form with the positive here. To move that into slope intercept, I'm going to distribute the 1/3 and isolate the y. So if I distribute the 1/3, I have y minus 5 is equal to negative 1/3 x minus 3, because I'm looking at 1/3 of 9, and I have a negative. And then I'm going to add the 5 to the other side. So that's going to leave me with y is equal to negative 1/3 x plus 2. And then from here, I want to put this into standard form. Well, standard form, we'll come up here. Standard form is ax plus by is equal to c, where a is a positive whole number, so it's a positive integer. So, and x and y are both on the same side. So I'm going to work with this part right here. So I have y is equal to negative 1/3 x plus 2. And just like my standard form, I need x and y on the same side. So how do I make that happen? I'm going to add the 1/3 to both sides. Add the 1/3 x to the other side. So I have 1/3 x plus y equals 2. Well, that's all happy and go lucky, but this is not a whole number. It is positive, but not a whole number. So how do I get rid of that denominator? I'm going to multiply everything by the denominator of 3, so that's going to reduce there and leave me with just plain x. I'm going to distribute to the y, that's going to be plus 3y, and distribute to the 2, which is going to give me 6. So there I have it in standard form. Example 3, write an equation of a line in point slope and in standard form that passes through this point and is perpendicular to some other stuff. So I have my point, which is 1 and negative 5. My slope, though, is originally 1/8. If I want it to be perpendicular, my perpendicular slope is equal to, I'm going to flip the position, so 8 over 1, and make it negative, so I'm looking at just negative 8. So let's start in point slope. Point slope is y minus y1 equals m x minus x sub 1. So we're going to just plug in where this is x1 and y1. So y minus negative 5 is equal to negative 8 of x minus 1. The only thing we're going to do here is just clean this up where I have two negatives next to each other and make that a positive, and this is my point slope form. So there's point slope, but then it also told you to write it in standard form. So from standard form, I'm going to take this y plus 5 equals negative 8, oops, I have an extra parenthesis there, x minus 1. I'm going to go ahead and distribute that negative 8, so I have a negative 8x plus 8, negative times a negative is a positive, equals y plus 5. Subtract the 5 from both sides, so y is equal to negative 8x minus 5.
With last names beginning
And last but not least,
L. I repeat, all sophomores with names beginning A through L, please go to the auxiliary gym for pictures.
Put this in standard form. I have x and y on the same side, so I'm going to start with this slope-intercept form. Y is equal to negative 8x minus 5. I need x and y on the same side. A has to be a positive whole number. So I'm going to add the 8x across the equal sign. So I'm left with 8x is equal, or 8x plus y, sorry, is equal to negative 5. A is a whole number. I'm happy and it's positive. So then there is my standard form. Go ahead and pause this video and see if you can answer the knowledge application and knowledge and understanding application and analysis, and see if you can either go as far as the synthesis and evaluation, and then when you're ready, go ahead and click play and see how you did. For 1, find the slope that is parallel and perpendicular to that line. Well, I would say my parallel slope is 3. My perpendicular slope is negative 1/3, because remember, that's 3 over 1. For 2, find the slope that is parallel and the slope that is perpendicular. My parallel is the exact same thing, so negative 2 over 5. My perpendicular slope, opposite reciprocal, so switch my location, so the 5 is on top, the 2 is on the bottom, and the negative is turning to a positive. For 3, write the equation of a line that is parallel to that jazz and passes through that point. Well, it just said equation of a line, so I honestly don't care what form it's in. So I'll put it in all 3, and if you had one of those 3, happy day. So I have a point, and my slope is negative 1/4. So if I started in point slope, I could say y minus 3 is equal to negative 1/4 of x minus negative 4. And the only thing I needed to do to put that in a point slope is make that a positive there, because I had two negatives. If you went further with this, I could have said y minus 3 is equal to negative 1/4 x minus 1. Add the 3 to the other. All I did there was distribute. And then if I wanted to combine like terms, I could add the 3. So then y is equal to negative 1/4 x plus 2. It would be in slope-intercept form, and if you chose to go that way. If you chose to put it in standard form, which if I had to guess, you probably wouldn't, but if you chose to put it in standard form, I would add the 1/4 x to the other side, so I have a 1/4 x plus y equals 2. This has to be a whole number, so I'm going to multiply the whole thing by 2, and that's, or whole thing by 4, and that's going to leave me with x plus 4y is equal to 8. And if you chose to put it in standard form. So 3 different answers there. For 4, write the equation of a line that is perpendicular to some stuff and passes through 5/8. Well, if I want perpendicular, the first thing that I need to know is my slope. And this is not in y equals mx plus b format, not in slope-intercept. So I need to make it in slope-intercept. So I'm going to start with a 4x minus y equals 2. And I want to get this y by itself. So I'm going to subtract the 4x to the other side. So then negative y is equal to negative 4x plus 2. And I need to divide everything by negative 1 to get y by itself, so y is equal to a positive 4x plus, or minus 2, sorry. Minus 2 because 2 divided by negative 1 is negative. So I know my equation of my line is y equals 4x minus 2. And if I want perpendicular, perpendicular means it's the opposite reciprocal, so my slope is originally 4. My perpendicular slope is negative 1 over 4. So I need to know that part, and it has to pass through this point. So I would start in point slope again and say y minus 8 is equal to negative 1/4 of x minus 5. And there is my point slope. If I want to go further, you can. This one does start messing with fractions, so if you want to do that, we can. If you got to that point, I'm also happy. But if you went further, negative 1/4 x plus 5 over 4, which you could have written as a decimal, but for right now I'm not going to, equals y minus 8. I'm going to add the 8 to the other side to get y by itself. And then that's going to leave me with y is equal to negative 1/4 x. And 5 over 4 plus 8 is 37 over 4, which is the same as 9.25 if you wrote it that way. But the reason I left it as a fraction is because if, and I doubt that you did, but if you put it in standard form and went one step further, I would have to add this 1/4 x to the other side. So I have 1/4 x plus y is equal to 37 over 4. But this has to be a positive whole number, so that means I need to multiply everything by 4, which leaves me with x plus 4y is equal to 37, because the 4 is going to cancel out here. So standard form, slope-intercept form, point-slope form. Again, I like point-slope if it doesn't tell me otherwise. For 5, write the equation of a line that is parallel to that and passes through in standard form. Well, I should be able to recognize that this is point-slope form, so that is my slope. So I know if m is equal to 2, and I want parallel, so that's all I need to know, and my point, x1 and y1. So again, start in point-slope form, so y minus 1 is equal to 2. X minus negative 5, so that's really plus 5. So now I've got it in point slope. Go ahead and distribute that 2. Cha-ching, cha-ching. So 2x plus 10 equals y minus 1. Go ahead and move that 1 over by adding it. So y is equal to 2x plus 11 is in my slope-intercept form, but standard form is ax plus by equals c, where x and y are on the same side. So I'm going to move that 2x over. So negative 2x plus y equals 11. Uh-oh, we have a problem. This is negative. How do I make it positive? We're going to multiply everything by negative 1. So a positive 2x minus y equals negative 11. And that is my standard form. Sorry guys, we are experiencing some technical difficulties, but anyways, if you are looking at number 6, find an equation that is perpendicular to the line that contains these 2 points, and it has to pass through 0, 2. So, for anything else, we need a slope and we need a point to write an equation. To find a slope, we're going to use these two because it has to be perpendicular to that line. So, I'm going to find the slope by using y1 minus y sub 2 over x1 minus x sub 2. And I'm going to plug in for my y1, I'm going to say is 3. My y2 I'm going to say is 5, so 3 minus 5, all over negative 3 minus 3. 3 minus 5 is going to leave me with negative 2, and negative 3 minus 3 is going to leave me with negative 6. I'm going to clean that up once more. Negative divided by negative is a positive, and 2 over 6 will reduce to positive 1/3. So there's the slope that it gives me, but remember, we want perpendicular. So if I want a perpendicular slope, I'm going to do the opposite reciprocal, which means I'm going to flip the location of both the 1 and the 3. So 3 is now on top over 1, and negate the sign, so it's instead of positive, it's going to be negative. Negative 3 over 1 is going to reduce to negative 3. Alright, so if we're going to go one step further, we're going to put this into an equation format. So we have the options of either we can use point slope, we can use slope intercept. I personally like point slope the best, so that's where I'm going to start. And I'm going to say y minus y sub 1 equals m, x minus x sub 1. So we're going to use that point. Oops, I don't know what I just did. I don't know what I just did. I think I just cleared all of it. Oh no. Can I undo that? Is that a thing? It is a thing. Sorry. So, and I want my slope of negative 3. So from here, I'm going to plug in my point of y minus 2 equals my slope of negative 3, x minus 0. You could leave it here for point slope. You could go a step further and put this and distribute it and to give you slope intercept form. So negative 3x, 3 times 0 is 0, y minus 2, and we can move that 2 over, which would give you y equals negative 3x plus 2, and this would be your slope intercept form. You also didn't even have to distribute that because this point 0, 2 is your y-intercept. So you could have just said, oh, I know my slope is negative 3, my y-intercept is 2, so you could have jumped here. And I'm going to assume that you guys probably aren't, but if you wanted to put this in standard form, x and y are going to be on the same side, so we're going to move that 3x over to that y, and that's going to give you a positive 3x, a positive y, equals 2, and that would be standard. So you could have any of these answer choices that you would like. Perfectly acceptable. Last but not least, for number 7, evaluate the value of x in line 2 that would make the two lines parallel. Well, remember that parallel means that they have the same slope. So if they have the same slope, I first have to find the slope of line 1. So I'm going to use my y1 minus y2 over x1 minus x2. I'm going to just go in order that I have. y1 I'm going to say is 11. So 11 minus negative 1 over 3 minus negative 1. These two subtractions are going to change to a positive. 11 plus 1 is going to give you 12. 3 plus 1 is going to give you 4. 12 divided by 4 is going to leave you with 3. So I know that the slope that I need is going to be 3 because they're parallel. Line 2 passes through these 2 points. So again, I'm still going to use this y1 minus y2 over x1 minus x2. So for line 2, I'm going to say 14 minus 7 over negative 2 minus x. And this is going to give me the slope of 3. Well, 14 minus 7 is 7 over negative 2 minus x. And from here, I'm going to keep that as equal to 3, but I'm actually going to write it as 3 over 1. From here, you might remember this from middle school math, and we're going to cross multiply. So what that means is I'm going to say 7 times 1 is equal to 3 times all of that. Negative 2 minus x. And all from here, we're just going to solve for x. So distribute that 3 to both terms. Negative 6 minus 3x. And it's going to be equal to 7. Solving for x, so we're going to add the 6 to both sides. I'm running out of room. So I have 13 is equal to negative 3x. And then last but not least, divide both sides by negative 3. Divide by negative 3. And I'm going to leave this as a fraction. So x is going to be equal to 13 over 3, but it's negative. And there you have it. So I hope that this makes sense, but if you have any questions, please let me know. I'll be happy to get back with you. And yeah, and I will see you guys tomorrow. Have a great day.